Okay, so good morning everyone. Today's agenda will do a little review on joins. We'll talk about the new join syntax. You guys are working on lab 3 right now, so we'll talk about lab 3 in more depth. So, if there are, if there's assistance needed for any solutions to the problems, then I can try and look at that. And then we'll eventually get into working with functions today. So, and then that should get you ready for lab 4 for you to start work on it. So, we're going to talk about joins. So joins in general is basically when we are working with two tables and need to leverage the link using the primary key and foreign key. That's how 95% of the joins use primary key, foreign key, but there are other operators that can be used. When we covered joins, we talked about equijoins, where an equality operator is used, and we also talked about non-equijoins, where all other relational operators are used. All other relational, other than the equality operator. Other than the equality operator. So to bring up the point of joins, we can look at the few examples we have from the few examples that we have in our PowerPoint. So basically in a join, we are doing one moment please. In a join, we are doing a select from multiple tables. So, and then when we do the join using primary and foreign key, the join condition is generally applied in the where clause. Say in an example like this, where we are selecting multiple columns, we have two tables and we have this as a join column. Generally, that leads to a Cartesian product, which basically means that if I have 4 rows in one table and 3 rows in another, and I end up doing a join, I am going to end up with a total of 12 rows in the result. And then we remove the rows that we don't want by providing this join condition. So, and then the fun part of working with joins is that we are able to create links between the two tables, and we are able to extract information by using the link. And I think the best clarity on this is provided with an example. And I've talked about the usage of EMP and department table before. So if I have employee number, employee name, and say department number as as table, as columns in employee table. I can have department number and department name as columns in the department table. So the way the linkage is made is like this. So if I have an employee named Bob in department 40, then I can go in the department table and basically figure out information about department 40, and every other column that the department table may have can essentially be brought in by this primary key foreign key link. The other thing to talk about here is how the Cartesian product works. So when we do a join, we are going to bring in, so our join code might look like this. We might say select start from EMP, comma department, EMP, comma department, where emp dot department number is equal to department dot department number. Everyone can see this? So for a join condition like this, what I'm going to do is when I create a Cartesian product, just the first two lines of the code, I'm going to end up making a Cartesian product, and these are the columns I'll have. So I'll have employee number, name and department number, and then department number again from the department table, and dname. So this is from employee table and this is from department table. So if I take the values at this point, I will have, for the Cartesian product, these values will repeat. And basically what it will look like is in the Cartesian product, both Bob works in both the departments. So we take the same idea and we, when we produce a Cartesian product, we also have corresponding rows for Dan. So we end up essentially with these two values. Now when we apply the join condition, which is this guy right here, employee.department number equals department.department number, I essentially am applying the join condition to these two, and then I'll be selecting these two rows. Right? I'll be selecting these two rows. So, and we'll end up with the final result. So one moment, guys. So these are the two rows that will be finally selected. So the result will end up being the following. So now when we talk about other types of joins, so notes wise, we've got inner join, which is what we just talked about. We also have outer join, and we have self join. And we actually traditionally talk about self-equi-join. So inner join is where what we just did, where we simply get the values from both rows that match. But there will be times when we will have a row in one table that does not have, like in this case, let's leave this null, right? We will leave the department number for Harry. We will leave that null. And we'll also say that there is a department number 55 called human resources that does not have any employees. So this is the concept of a inner join. So what I'll do is copy and paste this in the bottom so it's there for notes later. But let's talk about the concept of a outer join. Let's talk about the concept of an outer join. So we have in the outer join, we are going to show that Harry has no department number and 55 has department 55 in department table has no employees. So that's the point of the outer join, that we can show in the query, right? We can show the following result, that we have a department 30 or employee number 30 with employee named Harry that does not have a department number. So all this will be blank. We will also show that department 55 HR has no employees. And folks, the two colored areas, which I'm going to change right now, sorry, one moment. So these two, this is the part of the outer join, right? And this value, well, like, so these two are parts of, these two are indicating the parts of the outer join because I'm getting a department from the department table that has no employees. And I'm getting an employee which has, no department associated with it. Now the way we achieve this is by running a query where we'll put the plus sign either on the right side like that or on the left side. So left side meaning I'm gonna put it right here. So those are, left and right outer join, where we try and bring in information from table that doesn't have any corresponding rows, right? That's how an outer join ends up working out. So this is all part of the review. And then there is a concept of self-equi-join. So let me put this down lower in the notes for you guys. So I'll upload the spreadsheet for you all. And what I'm interested in now is just working with the employee table, which has an MGR column. And let's say Bob's manager is Dan, and he's also the manager for Harry, and Dan does not have any manager. Dan is the boss of the company. So in a self-equi-join, what we end up doing is we end up selecting in a self-equi-join, we will link MGR column with employee number. Now, why are we doing that? Well, MGR column is linked with the employee number. So basically what we end up doing is we want to find managers details like manager name, department they work for, etc. So what we end up doing is we end up saying, let's select employee number. So we'll say emp dot employee number, comma mgr dot. So actually, let's go ahead and select all the columns. So we'll say employee dot employee name, and then we have mgr dot employee number and mgr dot ename from employee, and then we'll select from employee table twice. And so when I say from EMP, comma EMP manager, as you can see here, then basically I'm making two copies of the employee table and trying to do a join between the MGR column and the employee table. So when we say from EMP, let's give this an alias of M so it's not confusing. So, which means I need to quickly correct this. So we'll say from EMP M, and you can see the two columns that are being selected, and then we'll say where M dot MGR is equal to E dot employee number. So that condition right there will end up matching the column, the MGR column with the employee table. So we'll be able to fetch we'll use this link of employee number 20 to select Dan's details. So So that's the self-joint. So I hope this few minutes of review is helpful. And if you guys have any questions, please let me know. Otherwise, I'll keep moving on to the next item. And this review that I've just done, I'll post these for you all to download. So let me just go ahead and save it. So you guys have it available with your lecture. So. Right. So Gianni, I'll cover that the new join syntax today with you all. So yes, you will be able to. You can use that. That's certainly a good idea. But just I was trying to cover the concepts first before covering that. So that's the new join syntax. So let's get to that very quickly. So we have some new join syntax that Gianni was talking about. So this syntax comes in the it's also ANSI SQL compliant it's compliant with the standards, and it will use the join keyword. So here you can see that new syntax, which is instead of using an equality operator, we use the word inner join. So we don't use commas anymore. Instead, what we are doing is separating the table name with the keyword inner join. So, and then we say on and do this part. So if the column name is exactly the same like it is in the case of department number column, we don't have to use the equality operator. We can use the word using and then specify column. So if we want to, we can technically join on more than one column if we want. So in that case, we would use using then department number, comma, another column. So column 1, comma, column 2, comma, column 3, and so on. So it is possible to join on, to do a join on multiple columns between the two tables. And you just have to make sure that the column names between the two tables are essentially exactly the same, and then it will work just fine. You cannot use column aliases, but you have to only use the actual column name when specifying the join condition. So as you can see in this slide, we have a column alias for department number called department. So, excuse me, we have so we are trying to use the column alias in case of this example, right, which may not service very well. And if we try and use if we try and use the table alias like we are here, that's also going to generate an error. So what we must use is just department number by itself, and that will work. But if you try and do either one of these, we are going to get a syntax error. So this is a code for inner join, and as I mentioned earlier, that if there are multiple columns, then you can have whatever you have in the select list. You can use the on keyword or the using keyword like this. So the on keyword will basically, if the column names are different, in the two tables that you're joining, then what you can do is simply use the column names and specify the conditions, whether it's a equality or non-equality operation. But when the column names are identical in the two tables, then you can use the using keyword between those. So you're also conversant now with outer joins, as I explained earlier in the lecture. So Oracle 9i supports that. The new syntax is supported using these keywords. Version 9i or later supports it. So we say select from table, and we can say do a left outer join, a right outer join, or a full outer join. And then we specify the two tables. So, okay, fairly useful. It is a shortcut of a sort, if you will. So what does left and right do? It generates null values for the side that doesn't have corresponding rows. So left, like you said here, null. Left, the word left will specify the results using all rows from table 1 with null for those rows in table 1 that do not have corresponding rows in table 2. And then when we do a full join, it specifies the results from both tables. It basically brings out all the rows. And then we have outer join. The word outer specify the results to be null using all rows from table 2. So this new syntax is extremely useful, and you guys should be able to use this in your current lab assignment if you so choose. So we are using on and using keywords. It just reduces the amount of typing to be done, basically. And we also have, if you want to perform a union, you don't have to do that anymore. You can simply use the full outer join. You may recall that you cannot use the plus operator twice in a condition to generate a full outer join. That generates a syntax error. So we have to do what is called a union. So to refresh your memory on that really quick, let me pull up a slide so we can talk through the so if I try and use something like this, where I try and use the plus operator twice. This is in slide number 19, I think, right? Slide number 17, excuse me. So if I try and use the plus sign twice in the same condition to try and initiate a full outer join, then that will generate a syntax error. So instead of this, what I have to do is I have to do a full outer join, as you can see in this slide. So I'll do a right join and then use the keyword union and then use the left join, and these queries are exactly the same. The queries are exactly the same, and the only difference is the usage of the plus operator on one side. So that's a lot of syntax, and if we ended up doing a full outer join instead, using from table full outer join and then specify the name of the second table, we're done. So it produces the results much quickly. So okay, so it produces the results quickly in the sense that you have less amount of syntax to cope with. So then we have something called join view. Join view is basically a table, a virtual table we create that is based on a join condition. So a view is basically, we use the create view clause to create this, and so we write our select statement with the create view clause. So, and when we create a join view, we are basically creating a virtual structure, and we are able to select data from multiple tables and put it in one single view. So maybe what I can do is cover this topic on next Tuesday instead of covering it today. So you guys we can focus on functions and chapter and lab 4. Okay, so because join view is it's an interesting topic, and it will also take a little bit of time. So I'll put this on the agenda for next Tuesday. So to move along, I want to spend a little bit of time on lab 3. And I know you guys have been working on this. So in assignment 3, there are essentially 5 questions. And so now that you have started to attempt this, the first question is basically using a self-joint. So when you're trying to print manager's name, right, not just MGR column, but manager's name, you have to do a join with the EMP table. So I'll have to say the following in the query. I will need to say select e.emp number, e.ename, e.hire date, and m.ename from empe, empm, where m.mgr is equal to e.employee number. That query right there should do a self-join and print out the name of every manager, right? And then we have to say manager's name starts with key M or S. So now you have to basically add additional conditions in this query to eliminate all names that do not start with key M or S. Okay, so that's my hint on the first one. Here we are basically saying create a query that will display employee name. So we have employee name, department number, and department name from EMPE, department D. So, and you'll of course need to join on the department number. So what we are trying to do here is that we are saying that if employee number 1445, it doesn't exist in the database, I'm sure, I'm just making this up. If I say if employee number 1455 is the given works in department 10, then let's select all employees in department 10. Okay. So to bring all employees that work in the same department as a given employee, you can use a query in from clause, or you can add a subquery in where clause. So Nabila, on the question of does this violate the condition of number of conditions? No, it does not actually. You can have, so the rule that you're talking about is the rule for the number of join conditions. You can have additional conditions to rule out rows that you don't want after the join condition is applied. Does that make sense? So So you can certainly add more. So these are the hints for number 2, folks, that that I can provide. On question 3, it's actually a join between, it's an inner join between department and employee table again, and then looking at writing an additional condition to simply remove to simply select employees that have job title as clerk. And that's it. So 4 and 5 are on outer joins. So you have to insert a new row in the department table, and you can look at the script in lab 2, in assignment 2 for help on insert statement. And this is a question on outer joins. So obviously, since you are inserting a new row right now, department 50, and you're not inserting any employees, you're going to have a row or no rows in the employee table for department 50. So you can do an outer join showing department 50 has no employees. So which means you got to use the plus operator somehow in the join condition. For number 5, what I've provided you is with a little help script, which is linked right here. And if you download this, just run it and use it. So then you'll be fine. So what we are doing is creating a new table called employee 2. So we can have a bunch of bunch of department numbers that are null. Like these last 3 in the bottom that you can see. Right, we've got plenty of employees in department 10, 20, and 30. And then we have got 3 employees, Scott, Adam, and Miller, that do not have a department number associated with their record. So basically what we do is we do this selection and we do another outer join. So don't try to the point I'm trying to make is, please do not try to insert a null department value or null department number in EMP table. It will not work. So please use EMP2 in help script. And then the hint is to perform an outer join for the solution to show employees that do not have a department number. Okay? When we insert for question 4, we will receive error. No, you won't. Why would you? I mean, you would in question 5. That's why I'm giving you the help script. So can you explain why you might get an an error when we insert, because in question 4 we are inserting a record in the department table, which is a parent table. It's not a child table. So you're not going to have any issues adding a new table. You will have so that insert statement should work. So because there is no referential integrity issues that we are trying to tackle. If you were to delete department number 10, and because department number 10 has employees in the employee table, we will have trouble deleting it. But adding a new department should never be a problem. So, okay? I hope that answers your question. If not, please let me know. All right. So the next thing, are there any questions, folks? Any other questions on Lab 3 that I can help address? So if you continue to get an error, please email me or put it on Piazza, the error you're getting, and we'll help you troubleshoot it, Mohammed. Does that work? Let's do that, please, so I can. You can email me, and I can help you figure out the syntax. I mean, I think your syntax looked fine when you texted me, and if there is some other error, then we can look at that error and help you troubleshoot it. Yeah. So, any other questions on Lab 3 that I can help address? Because Lab 3 is coming due shortly. So, if there's anything that comes up, please email me, get in touch, and I'll be happy to assist. Let's talk about SQL functions. That's our next topic. So SQL functions is a chapter that is going to be, I guess, quite a bit of information overload. So I would just try and understand the different functions that we have, and then Lab 4 and 5 both require you to use these functions in the assignment. So the idea would be to not try and remember everything here, but just like try and understand as much as you can. So we have different types of functions: single row function, group, and subquery. So single row functions work on one row at a time, and the idea of a function is the idea of a function is that it will take multiple inputs and it will return one value or one result. When we talk about different types of functions, we have single and multiple row. Single row works on one row at a time. Multiple row, take multiple rows and return one value. That's an example of a group function. So like finding an average of 5 rows, you know, finding an average of 5 salaries or something like that. Multiple row function or single row function have these properties. You can manipulate values, returns one value, acts on one row, returns one result, uh, returns one result per row, and it can change the data type and can also be nested. So each one of those things is going to be exemplified nicely in the slide deck. So these are different types of functions we have. So how does this work? Well, we have character functions. So if you want to work on strings, you've got all these wonderful functions at your disposal to use. We have case conversion and character manipulation functions. So lower, upper, and init cap are case conversion, and these 6 right here are character manipulation functions. You obviously want to know how each one of these work. So here is the case conversion. I mean, as you can tell that there's a lot of subject matter. It's kind of dense, but it's really more for reference than like knowing all these functions. You know, it's not the same as joins is what I'm trying to say. So I guess what I'm saying is you can take it a little easy with functions because you just have to look up and use. Lower, upper, and init cap, you can see the results, right? You can also see the usage of these functions in a query. We can put up a function in the select statement to display the result in uppercase. We can put it in a where clause to convert. So all kinds of, there's multiple places where these statements can be used. Here is the character manipulation part. Concatenate will concatenate 2 strings. Substring will bring part of the string out. Length will tell you the number of characters in the string. In-string will search for one string inside another. So LPAD basically will add a character specified for the unused area. So like if salary is 5,000 and we have chosen our total spaces of 10, it's going to put 6 asterisks in the beginning with the value 5,000. So then we have trim, which basically will remove a character or a string from another string. Here is the some of these functions in play. How concat length in string works. Okay. So then we have a series of number functions: round, truncate, and mod. So we have round, which in this case we'll just round the value to the defined precision. Truncate, same thing, but truncate just chops the value, it does not round. And mod is just keeping the remainder of the division. So you need to understand LPAD more. Sure. So when we say LPAD, we have a column value cell. So that value can be 5,000 or 20,000. I mean, it can be 5 or 6 digits or 7 digits, whatever value. 10 is specifying the width. An asterisk is representing a value or a character that will be used for the unfilled area. So in other words, if I say a value of 7 digits, so actually let's just make it easier. So based on what is specified in the slide, if I have a 7-digit value, this is what the output would look like. So the point is that it's using an asterisk for the leading spaces. So similarly, if I have a value of sal that is only 1 digit, then all these 6 spaces will be filled with asterisks. And so I'm now using a total of 10 spaces like that. Does that clarify? Or if not, please let me know like what specific question you may have on LPAD, and I'll be glad to clarify. So here is the demonstration of concat, length, and in-string. What you all may consider doing is trying these functions out on your own, which I think will help more than anything else. Because just being able to look at the output and trying out variations of these functions is part of the learning process. So here is the round, truncate, and mod in operation. Here is round in more detail. So if I round to a precision of 2, 0, and -1 with the same value, see what happens. When I round to a precision of 2, I get 45.92 because 3 is less than 5, the last precision value. When I say round to a precision of 0, I get 46 because 9 is greater than 5. And when we get to -1, this is really going into the integer value, and if this was 44.923, then this would show 40. But because it's 45, it's now showing 50. Okay? Truncate does not round. It simply eliminates part of the value. So you can see what's happening here is with 45.923 with truncating at 2, there's no rounding there's no rounding happening. With 45.923 by itself, which means essentially 0, it prints out the value 45. And When we say -1, it prints out 40. Okay. And then we have the mod function, which is printing the remainder. And this could be used to essentially say if the salary is greater than commission or not. I don't see another usage, like practical usage of the mod function. Then we have the date data type in Oracle. The date data type stores all these properties in numerical format, starting with century all the way down to seconds. It has a default mode of a 2-digit day, 2-digit month, and 2-digit year. There's a predefined function called sysdate that basically returns the current date and time. And we can use sysdate function for if you want to record when a value is saved in the database, etc. So dual is a dummy table that is used with sysdate when you pull out the value. So like if I was to say select star from sysdate, that's really referring to a temporary table called dual that is used by the database automatically. So there are mathematical operations like add and subtract that are available with the date data type. So you can subtract 2 dates to find a number of days between those dates. You can add hours to a date by dividing the number of hours by 24. So on the truncate, there's a question back on when we say -1, why is the result 40 and not 44? You see, when this value of -1 or 2 is specified, that is number of digits in position. It's not subtracting 1. Do you follow? So we're saying that when we say truncate 45.923 comma -1, when we are saying this, we are basically saying we want to only focus on the second unit of the whole number. That's why it prints 40, and it basically rounds down the value 5 to 0. Does that answer your question? And if you truncate 45.932 with -2, then it should be 0. Yeah. Right. Okay? All right, good questions. So arithmetic can be done with dates like this. Not everything can be computed, but some of these things that are specified can definitely be. You can add or subtract dates to get a new date. You can subtract 2 dates to find the number of days between dates and hours. So here is the usage of some of those operations. So based on today, subtract the value of the higher date, divide that by 7 to figure out the number of weeks somebody may have worked in a company. So that is one nice convenient operation, if you will. So these are all the functions that allow you to do the some of the mathematical aspects we talked about. So we have months between, add months, next day, last day, round and truncate. Yes, we have round and truncate for date data type as well. So here we go. Months between two dates returns a value. That's basically saying it's 19.67 months. This the default calendar type used in the Oracle database, I think, is the Julian's calendar, although those parameters can be changed on add months. So if I have to say that I have to do a review for a person 6 months from now, that can be just start date or date, comma 6, and that'll add 6 months. Next day, this function returns next Friday from 1st September 1995. And what is the last day of the month? And then this is how round and truncate works. If we try to round the month or the year, or we try and truncate the month and the year. So you can see the results here. Like 25th of July, rounding to month gives us the first of the next month. Truncating that gives us the first of the same month. Rounding the year takes us to the beginning of next year, and truncating a year takes us to the beginning of the same year. Okay. Some functions on the date data type. We often have a need to convert um, the date data type. So we have these implicit and explicit conversions. Implicit is when the database server does these conversions automatically. Like varchar to and char to a number, or varchar to or char to a date, right? And then we have number to varchar to or date to varchar to. So if you end up, say, using a function where you provide a varchar to a number input, then that data type conversion will happen automatically. So this is for value assignments, and this is for expression evaluation. So when you have operators being used between different data types, a varchar to or a char will automatically be converted to a number or a date data type. So that's the key point of this slide. You have a set of functions available to do explicit conversion. So you can see there are three possible data types: number, char, and date. To convert anything to a character or an array of strings, you can use the toChar function. And if you're converting a character to number or a character to date, then we'll use the toNumber or the toDate function. So Here is the toChar function. We are going to demonstrate both the usage of toChar with number and toChar with the date data type. So when working with dates, we provide the value of the date in this first parameter, and then we provide the formatting, which is usually kept in single quotes. Now, the formatting is expressed using this data, using this format model. So if you were to specify full year in numbers, or spell out the year, or spell out the month, or spell out the day, you know, we can do that. So like this. So if you want to show military time, you're going to see the first example where we use the 24-hour format, showing hours, minutes, and seconds. If you want to show some additional strings, then we can put those in double quotes. So here it says DD, which is going to show the day as a two. DD is basically a two-digit day, and then we use the word month that spells out the name of the month. And DDSPF is going to spell out your numbers for the day. 13th, 14th, etc. So net, the features that are available for working with date data type are quite detailed. So here is the, after having looked at how the date is specified and how the formatting is specified, you can see a function in play, the toChar function in play here in the select statement. So we are just saying select ename, and then we are showing the higher date with the month spelled out with the exact date and the 4-digit year. Okay. Here is toChar working with numbers. So if you're trying to format currency and if you're trying to format currency or something like that, you can use the number formatting. So you specify a number and then a format. Now the format model for numbers is in front of you here. So I think it'll be best to see this at work. So then you can apply it easily. So let's look at a few examples. If I'm just trying to print 5 digits, I'll just use 9 multiple times. And I can throw my comma separator. I can say dot operator to specify the decimal point, as you can see in the bottom. I can use L to print the local currency. The local currency is usually specified at the database level. It's one that is used for all. So it's not like you can change it or vary it, right? So to convert a character string to a number or convert a character string to a date, that's additional. There are additional functions for doing that. Now the nice thing is that the formatting part that we have learned is the same. The formatting part that we have learned from the toChar function applies to these functions as well. So, okay. So let's have a look on how both of these functions actually work. So the formatting criteria that you're going to provide is going to be the same. So it's going to be the same as what we did for toChar. When we are working with the date data type, there is a RR date format that needs to be understood. This was the format that caused the problem when we were working with 2-digit years. So back in the day of when we were going to go from 31st December 99 to 1st January 2000, we had this very popular bug, the Y2K problem that we were dealing with. And that had to do with the representation of the 2-digit year. Not pervasive today, but when you are working with 2-digit years, this is what can happen. So if you're working with current year and specified year, just let's go through these 4 rows together to understand this. You'll very quickly see that, like in the first row, when it's 95 and the date specified is also in 95, in both the formats, the year is perceived to be 95. But if the current year is 95 and the date is being specified in 2017, then RR format perceives it as the date in 2017, but the YY format perceives it in 1970. Go back and look at 2001, we don't have an issue. So if we go back to current year is 2001 and the date being specified is in 2017, in RR and YY format, life is good. Now we come to the new century, 2001, and the date specified is also 27th October 1995. It's past the 50-year. Then the year perceived is 95 and 2095. So the point of this entire slide is to always use 4-digit years when printing out. Never try and use a date format in 2 digits. So that will most likely eliminate most problems. We also have an NVL function. that we have talked about before. NVL function is type neutral. So it can be used with date, character, or number. So the way we end up using NVL function with the different data types is shown on the slide. And you can basically specify a default value. So we have, for example, with numbers, the value can be 0. With date, we can specify a default date. And with job, we can just, or with a string, we can specify some default string here. So why do we use NVL function? To convert null to a relevant type. Because if we do not use the NVL function, then the result will become null. So for example, in this case, if I said salary times 12 plus null, then the result delivered in that highlighted column will be essentially a null value. So null value is useful to describe a condition where, especially when you're working with operators like I showed you, we will end up with just anything, any result of any operator applied with a null value becomes null, and that's basically what we're trying to avoid. The decode function provides an if-else type setup. So we can say that if job is equal to analyst, then give a raise of 10%. If job is clerk, then 15. If it's manager, then 20. And if it's none of these three, then leave the salary alone. So you can see the salary of president doesn't change, but manager goes up by 20% and so on. Decode function is useful for these writing an if-else statement inside a function essentially. Here is decode function applied for tax rate, for computing the different tax rates. So as you go through this chapter of functions, you're going to realize that there's plenty here from information perspective. But the point is that are you able to apply some or parts of this for your lab assignments? We can also nest functions. So you can, which basically means that with single row functions, we take the output of one and put it as input into another. So here we are nesting three functions. So result of F1 goes to F2, F2 goes to F3, and so on. Here is an example of how functions can be nested. You've got the MGR column in the employee table that can possibly be null. So we convert that to a string, and If the value is null, we pass that into NVL to print no manager. So in cases where there is a manager there, then we do not. So I think what I'll do is stop here for today. You guys are working on lab 3. I'm sure you're going to, once you're done with 3, start to attempt 4. And you would have gone through a little bit of a tryout on 4. And what I'll do is next Tuesday cover help on lab 4. We'll talk about group functions and subqueries. And we'll also bring in creation of views with joints, which is an important topic as well. So this is all for today, guys. If you have any questions, let me know. I'll be here. Otherwise, have a great Tuesday, and I'll see you all next week, same time, same place.